As part of the module 3 that we are discussing, that is ETL with the Spark SQL, so we will discuss creating the delta table as the next concept. So if you are following the series of videos that we are presenting, or we are kind of uploading, so you might have observed that we might have already seen how to create delta tables in the previous videos as well, but this video is specifically for creating the delta tables, because there are different ways or different methods that you can create delta tables. So it is quite important to understand all these methods of creating a table, because if you are from SQL background, right, there you will just create a table using a create table syntax, and you need to provide the column names, and like if you have any partition columns you can give that. But here it is quite interesting that you have different other ways to create tables in Delta Lake Databricks, right? So we need to understand those concepts in a much better way, so that we can utilize this option where and when required. And before actually getting started, right, so you need to also understand that we have discussed, we have been discussing about the delta tables, right? And what is the, we need to understand what is the benefit of delta table. So usually what happens in the organization when you're when they are bringing data from the multiple sources, like using ELT or ETL kind of process, right? So what generally happens is they will be doing some exploratory kind of analysis, or they might be initial stages of the project, and they are not aware of the data types. And even though if they are not aware of the data types, there is very less chance, or where there is no chance of data getting corrupted when you are using delta tables. If you are using like a normal SQL kind of a format, if the data the declared is like a string, but the data coming is a datetime or timestamp column, right? So then there might be data corruption or such issues when there is a data type mismatch or something like that, right? Here there is, when you are using the delta tables, that's the advantage. There is no problem of data getting corrupted because of the structure. So why is that? The main reason is the delta table, the concept it uses is it uses the concept of schema on read. It will actually, when it is reading the data, then only it will apply the schema or the skeleton on top of it. So but if you talk about the regular databases, SQL, Oracle kind of a databases, there the table will be there, then you will write the data into that table, right? So that is a schema on write. So when you're writing it, only you will need to have a particular schema and you need to write it. But here what happens is schema on read, so there is no problem of data getting corrupted, because there is a clear separation between data and the structure here. So that is the advantage of using delta table. And with that we will proceed uh, regarding this video. And before proceeding, if you are new to this channel and haven't subscribed for this channel, so we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So creating delta tables, we will see this in the demo, right? What are these is like using CTAS, that means create a table as a select. So how do we use this? So if you're from SQL background, so this might look completely new for you. So if you are from a Hive kind of background, big data background, you might have heard this, or you might have familiar with this, because Hive also is something similar to this. And we will also see using existing views or tables, how can we create a delta tables. And these are about the creating delta tables, and also we will see about how to enrich loaded data with the additional metadata. How can we add a metadata so that it will kind of enrich the existing data, right? So that we can use with the additional metadata. How to enable that we will see. And we can also provide a table level description and column level descriptions, okay, so that it will be, the table will be more readable, and you can think about the documentation also in that case, right? And there are few advanced options also during creating the table, like you can specify the location. I think if you are following the previous videos, you might have already encountered wherever we are giving explicit location, that means it is an external table. Otherwise it is just a like a managed table. So that is the location we are discussing. And qualify enforcement and partitioning, we also see how to kind of this is like enforce the quality, and also define the partitioning column, and why this partitioning is important, right? So this concept we will discuss in the demo. And without any further delay, let's get started with the demo. So now let's quickly jump to the demo and see the the live creation of the delta tables, right? And currently we'll start with CTAS, what we were calling, right? C is nothing but create, T is nothing but a table, A is as, and then S, create table as a select. That means here what we are trying to do is we are already selecting a table, okay, which is existing already, or we can also select the path of the file, right? And doing that select statement, basically we are doing a select of a table or a path and then providing the data to the create table. So that means we select, it will take the schema of the data which is selected, right? And based on that schema it will create the table. Okay, so as you see, students table is already existing here, and let us kind of execute this statement to create a students new based on student table. That means it will create all these three, I mean, data types that we already have. I mean, the columns with the proper data types for all these three columns. So let us execute this and see. Yeah, as you can see, it has we are able to describe the new table also, and you can see it is a managed table. Why it is a managed table is it is, we are not giving any location for this, and that's the reason it is storing in dbfs, and there is no mount point here. Okay, so similarly we can do something different also, like in the previous video we have seen how to read a file as a table. In the previous video I've seen, if you are not seen that video, you can go ahead and see that video to understand better about this. But there is another way, like you can give the file format like JSON, Parquet, and text binary file. So you can give the different file format. This is a file format which is a keyword, and then followed by the location of a file, exact file or set of files which are having a common schema. Like currently I'm reading a JSON file location. If I show you the JSON file location here, I uploaded 4 files which are having the same schema. So all should have a same schema. That is where I am giving the folder itself. Okay, these if you see the apple.json, you see fruit size and color. Okay, and similarly banana, orange, pomegranate, all these JSONs will have a similar schema. So that is where I can just read directly the folder instead of files. Okay, so let us try to execute this and see. So let us try differently, right? So instead of just doing a select from the blob storage, we've already tried this in the previous videos. So let us try that uploading the same JSON files into the data lake storage. So this is a data lake storage, and if you see, like in the previous video we have already seen this, how do we mount this data lake storage with all these options, right? If you are not followed that, please check that video. We have explained in detail about the mounting the ADLS as well. So we will use the ADLS mount point here, that is a ADLS location, physical location, and read the files. Let us see that whether it will work. So we are doing a select start from JSON dot the location of the JSON files, right? And since this is a mount point, container temp is our mount point. It is a root folder, right? After that you have a JSON files. So that is why this is our root folder. After that we have a this folder, and you are reading the folder itself with the entire JSON. And once we do this, we are able to see all these records. And now let us do a CTAS. That means create a table as select. So you are using a select statement and then creating a table. So let's try this. Yes, we are able to kind of create a table using that. And if you kind of describe this fruits table and see, let us see what exactly the metadata about this table, right? So this is a managed table, because even though you are reading from an external location, but the table, when you are creating the table, you are not giving any explicit location. So that's why it's still a managed table. That is an internal table for Databricks. So now that we have done CTAS kind of a syntax, we have used that CTAS kind of a syntax to create a table using the existing tables or using the existing the file format. You can here use instead of JSON, you can use txt, CSV, or binary table also format if you have that kind of file formats, right? And with that we will also see how to create a temporary view. So why we want to create a temporary view? Let us understand after this, right? But first let us create a temporary view. Okay, create a temp view. So you can also use create or replace a temp view. Okay? You can also use that syntax. Since I'm sure this view doesn't exist, so I'm using this syntax here. View students. Okay, and then here what I'll do is select star from, or else let me use fruits, okay, that we have recently created. Select star from fruits. This is the table that we have created, right? So what we are telling is that we are able to create a temporary view also using the. So what is the error here? So we just need to give a as. Right? So what we are going to tell here is we can also not only we can create a table using this CTAS, we can also create a view using CTAS. Okay, and then also in the reverse way, right? You can also create a table using a temporary view. So now we have this view fruits. So again, you can use this temporary view, right? So select from start from this view, and then create a table using this. Select start from this, and then create a table fruits underscore v1 as. Okay, so we can do the reverse also. That means read from the view and create a table. This is also CTAS of it. Okay, so this is about the playing around with the different CTS options. You can create using the, I mean, you can create a table using a location. You can create a table with existing table. You can create a table with existing view. You can create a view with existing table. So there are different permutation and combination you can think of here. And also next, as part of the same CTS, right, we will see the different options, right? Like, so as you can see, when we kind of query this fruits table, let us query the fruits table, right? So this is a fruits table that we have created. So let's start from fruits table, right? V1. So you can see we have used the CTAS everywhere, and when we are doing CTAS everywhere, previously we were just doing a select star. Okay, so we can also do a select a particular rows when we are creating a table. Let's create a V2 table using the same CTS format. Create a table as, so just let us give fruits underscore v2, right, and then do a select. So I'll just select a color comma fruits. I don't need a size here, right? So in that case you can still do that from fruits 1. So it will create it will create fruits 2 with only these yeah, it is just fruit. So it will just create a v2 with only 2 columns. So that's quite important to understand. And similarly, like if you create a v3, right, so you want to mention color as COL and fruit as FT. Okay, so that even that can be done using the column aliases here. And if you kind of query this F3 table, you will see the table which is created with the alias names, not the actual table names. So that's the beauty of CTAS. You can use this way also. Similarly, we have done for tables. You can do the same thing for views as well. Yeah. And we have seen CTS statement. When we are creating a CTS statement, it will just read whatever the previous column names were there, okay, of the main table, and also if you are doing alias, it will take it. But nowhere there is an option to kind of work on the schema declarations. Okay, that means you cannot control the data types. If you are defined something as a like a timestamp, okay, it might appear as a timestamp to be some variant of a Unix timestamp. So in that case, it is not useful for our data analysis, right? So this is a situation where we want to have a generated columns. So that means auto generated values, right? We call. So let us see how it exactly looks and how we can make use of that. Yeah, as you can see, we are creating a purchase table date. I mean the table here, and the first three columns looks very simple. You will be knowing it is a string, string, and string. But the date we are defining it as a date. We are using a generated always as. Okay, generated always as will make sure that it will be auto generated whenever you are adding a values to this table, right? This table will be auto populated, and also you can give the comments. I mean, what exactly you are trying to do here is you are just generating based on the transaction timestamp. So this will be useful for the documentation. So anyone who sees this table definition can understand it. So now that we have kind of added this, created this table, right? We'll try to insert some records to this table. And as you can see, there is a check constraint. It actually fails. So as you can see, it is clearly showing check constraint and generated column. That means this is a particular generated column and you cannot specify the column here. So let us try without the column. And still it is throwing some error. So let us try this quickly, different thing, right? Let us create a purchase table, one more purchase table, which is just having these values without a generated column. And let us name it as old. Okay. And with this we will try to insert a value into this be old table, right? Instead of the actual table, we will first insert to the old table. So once we do that, we will kind of try to merge the old table to the new table. Okay. So the new table is purchase. Okay, purchase underscore dates, and the using is purchase dates old. So using purchase date old, we will match it and do it. And this is important to set this auto merge enable to true. Okay. And let's try to execute this. Still we are getting the error. So whether you merge it or whether you insert it, we are still getting the errors. So now let us understand this using the table constraints. So there are different null check or column checks basically you can add. Okay. So these are basically to kind of have the data restricted before actually it get inserted. So whether it might be a not null checks or like a check constraints. There are two varieties here. So let us first check about the check constraint. Okay. So the check constraint, I mean, you can use it when you're kind of creating the table also, but or else you can just alter the table and add the constraint. So we will do the second one now. So what we will do to the purchase dates table, we'll add a constraint called valid date check greater than this particular date. Okay. So you have successfully added the constraint. And then if you describe the table how exactly it looks, right? So let us see about that. So this constraint, whether it will show, let us see that. Yeah, I can see the table properties. It is showing the constraint, that is valid date is nothing but it should be greater than 2020 0101. Okay. So next we will understand how do we enrich the tables with additional option and metadata. Okay, so what does that mean, right? So we have seen CTAS to include the number of additional configuration and metadata. So now we will kind of use a select clause basically, and when we are doing a select clause, we can include a current timestamp to get the current timestamp of the the current system time, so right, when the logic is executed. And also we can use input file name, which actually records the source data file from for each record in the table. Okay, let us see that how to do that, right? And also we'll also see like when we are creating a table, we can give the comments, we can give the location, and also we can do the partition by a particular date column, or like say location, so where you can access the data in much faster way when you are using a partitions, right? So partition basically is a primarily, I mean, we can give it as a syntax, okay, when we're creating a table. And what it does is it will create a small or medium sized data in a particular folders, which will benefit from that partitioning, and physically it separates out the data files. So then the approach can result in a smaller chunks of files when we are reading it, writing it. So that exactly it helps actually, okay. And the benefit is observed when we are especially using in Hive and like Hadoop distributed file systems, HDFS. It will be more useful, the partitioning concept, right? Yeah, to start with, we will see how can we do a like a timestamp that you're talking, right? How can we check that? Basically, when you just add a like a current timestamp and do from a fruits table, right? So you can, this table is optional here because we are not anyway selecting anything here. You can just skip that, and if you just do current timestamp, you will get the current timestamp. But if you want to do that with a particular tables, so it will display number of times the number of rows exist in the fruits table. And also if you kind of want to look into all the records here, you can just give comma star. So current timestamp is first column, and other whatever the rest of the columns will be displayed. And also it is important to understand here the input file names. That means from where this particular record is coming from. So this will be useful when you are working with the large scale data, right? So understand where exactly the data is coming from. If you see, this data is coming from this parquet location. So you have created a fruits table, right, using a location. You read a file from external location and written into a managed table. Since it is a managed table, so it is writing it into a Databricks file system as an internal table, that is a managed table, and writing it as a parquet, which is a default format of the Databricks. So you can see each and every record has been stored in a different file. So it doesn't mean that you should store them in a different file. You can store them in a single file as well, but so it again depends like how are you doing a partitioning and other concepts. So we have seen CTAS, right, where we will kind of get the schema of a particular table and also the data of a particular table, and then using that we will create a new table. But that is just a copying, right? So that is a copying, but there is a concept of cloning also. So how the cloning will differ from copying is when you do a cloning, so it actually copies the entire data and also metadata from the source table to the target table. So that is the difference between cloning and the actually CTAS statement that we have used. So how do we do that is create table fruits v3, yeah, v4, deep clone fruits. Okay, so what exactly, I mean, why we are using deep clone here, right? So instead of CTAS, we are seeing here we are using cloning, that is also deep cloning. So there is a difference. I mean, there are two kinds of cloning. There is one is called as a deep clone, so which exactly like fully copies the data and metadata from source to target. So that's what it is doing here. Okay, it will fully copy the metadata information also along with the data. Okay, what that means is if you are having any kind of a like comments, any kind of partitions, anything that you have created, right, it copies everything to the target table. And there is something called as a shallow clone. So you might have already understood that syntax. It is just instead of deep, you have to mention shallow. Okay, just replace deep with shallow clone here. Okay, and we will create a table as v5. So here what does this shallow clone means? Okay, If you kind of wish to create a copy of a table quickly to test out applying changes without any risk of modifying the current table, right? So you're just creating a clone of this table, do the testing, okay, and then so you don't touch that original table here, right? So it will not actually it's like a temporary kind of a table you can call. And shallow clones just copy the delta transaction logs, meaning that that does not move basically, right? That means you are not impacting any data here. So the transaction logs will be impacted definitely if you are doing if you want to do some testing with respect to the fruits table, right? But you don't want data to get impacted. Okay, so that case you can just do a shallow clone and clone it to a v5, and you can do any kind of a modifications or tryouts with the v5 table. It will not affect the data of the fruits table. The data will be kept separately. Okay, and only the transaction log will be shared between these two. But if you are working on a deep clone, what happens is everything is cloned from one to another one. So make sure that you use a deep clone when you want to kind of create a exact replica of a table into a different location, and you can operate these as a separate tables with respect to data and transaction log. But if you want to try out like some small testing you want to do, so then you can go for a shallow clone. So basically in either of the cases, data modification apply to the cloned version of the table only. So if you are doing this v4 or v5, the data modification will apply only to this, but what differs is the transaction log. In case of deep clone, even the transaction log will get it's a separate right, so it will not get impacted. But in case of shallow clone, even transaction log will get impacted, but not actually the data. So cloning is definitely, you might have understood, is a great way to set up tables for testing SQL code while you are still working in the development environment. Okay, so actually we have discussed primarily on the DDLs and syntax of creating the tables like CTAS tables, right? And how do you create a shallow clone tables? How do you create a deep clone tables? So there are different options that we have seen when we are creating a delta table, what we can call. And hope it was useful. Thanks for watching.